So I will speak about operation and maintenance, and I will also add some insights on the supervision of operation of such facilities. But a little introduction for myself. My name is Leon Kraversky, and I'm a graduate of a master's degree in nanotechnology with expertise on PV devices. So actually I got into this world some 13 years ago, which is quite much of a period. And over the years, I've been exposed to various procedures and long-term influences on the performance of such facilities, specifically distributed solar facilities, which are mainly rooftop. Let's be clear about it. And this led us, me and my team, to develop Soltell and its smarter solar management solution, which deals with quite several levels of problems in operation and maintenance of such facilities. So first of all, what we do is we provide solutions for supervision as well as operation and maintenance for solar PV. And this is governmental, commercial, and residential scale as well, even though our main work is in the commercial sector. Now, let's talk about the problem, which has been just introduced by Dr. Dersey. And this is actually the costs of O&M, which are quite high. We're talking about $19 per kilowatt per year, which is basically encircling operation, maintenance, including the cleaning, communications, and the parts actually already go beyond that number. But it is actually hidden in the warranty of inverters and panels. So when the warranty voids, you also have to add this another chunk of costs. Now, in this model, the lower the tariffs go, as you've seen, the higher, the lower the ROIs. The return of investment becomes pretty much problematic, and the only thing which you can do on the long term is actually looking on a radical reduction of all of those costs. And we also have to think about additional costs which are actually hidden. And this is very much relevant to the distributed solar PV and less so to solar fields in utility scale. And I'm talking about the part which is supervision, when you have multiple levels of solar operation, meaning there is an owner, there is also a service provider, and then sometimes there is a supervisor above it. In addition, there is probably also a supervision within each service provider company. And we also see the beginning of interest from regional energy providers, which want to know what is the situation with the solar PV in their regions. So actually taking the situation from this quite high cost model to something which is desired is quite a question of technology. And we have to break those down and understand how you can reduce those costs substantially while still improving the output of those systems without impacting the output, essentially. I will talk specifically about operation and maintenance and supervision as well. After me, Mr. Roy Sadeh will talk about the cleaning of the systems, which is very much costly, and it's an issue of its own. So, while breaking down, I think it's quite clear what's the operation of distributed solar PV is about. So we're talking about remote monitoring, and since we are speaking about different brands of PV inverters, as well as loggers, we're typically talking about aggregating quite several of them. We already have different aggregative remote monitoring tools on the market, but I think most of them deal with the operation itself, not beyond that. We also have to do insights, basically for each system, in order to produce the reports. Those reports are typically delivered to owners or supervisors, and then there is a need to alert the technicians in the field where they need to go, what they need to fix. And this, of course, has to be optimized. And this goes essentially to maintenance schedule of those technicians or subcontractors, which is quite common in distributed solar PV. But there are also two more issues we have to talk about, which also can be, in fact, theoretically at least, automated. So today's supervision, in fact, is quite manual, whether it's a supervision on the O&M by the company, by the service provider itself. So typically an O&M manager has to check by himself whether his team works well. And we quite frequently see the situation when roof owners check by themselves whether those reports are genuine and whether the work provided by the service provider is good enough. And we found out actually that many such roof owners, in fact, do the monitoring by themselves and spend quite a lot of time to do so. And furthermore, they also check the reports manually again to see whether everything works out as they expect. They also check electric bills. And of course, they rate the operation and maintenance quality, because in many cases, there are standards or contracts which they need to check. When the service provider is not standing up to their rating of quality, they often need to be changed. In maintenance, of course, there is possibility to automate various procedures as well. I will not talk about them too much, but basically this deals with tickets and escalation. And I will talk more about what we have developed. So our solution is industrial IoT automation, is basically utilizing the whole data from both inverters and also data which is dealing with the weather. We have to understand that in distributed solar PV, the ability to install sensors for radiation and temperature, which is quite common in solar fields, is becoming quite problematic, because you have to maintain those themselves. And when you have a lot of roofs, it is quite a challenge. So developing something which is sensorless was quite crucial for us. And this allows us full IoT automation, which also brings us to predictive maintenance. Of course, we don't need to install any sensors at all. And essentially, we move from qualitative monitoring and reports to quantitative, which also allows us predictive maintenance ability. And we also had an added value of maximum performance in many cases, except the issue of cleaning, of course, but this will be discussed later after me. So we're basically using the same platform for all levels. I will talk about them in the next slide, but this is how the platform looks like. It's more or less similar to all levels, whether it's owners, whether those are service providers or supervisors. We can simply provide different roles to everyone involved in the system, but essentially they all consume the same data. So in our view, again, we are aggregating data from different providers of inverters or loggers. We are also collecting data which is crowdsourced regarding temperature and irradiance. We completely reduce the need in installations of such sensors on each roof. We also don't need any regional weather stations. In fact, what we developed proved to be better, and it is on the level or even better than satellite sensing, which can be used for utility scale, but not for rooftops. So after the processing, we essentially provide all the information to all relevant parties, whether those are PV fleet supervisors, the managers of O&M, and the technicians themselves on the field. And the solar owners can get the reports, which they simply can read with the exact data and the exact figures without any need to check them by themselves. So basically, as mentioned, we are using two levels of technology. One is technological innovation, which is sensorless weather measurement. The other one is functional innovation, which provides also automation for supervision. And essentially, this allows us to give quantitative performance analysis and automated reports on macro scale, meaning we can provide automated management for hundreds and thousands of facilities. And this basically makes it relevant to the cities, to the city scale. So this is the outcome of what we did last year. Our average connected system size was 44 kilowatts, which is small commercial scale, but we have a wide range of them, between 4 to nearly 1 megawatt. The average number of inverters per system is 3 to 4, but again, it ranges between 1 to more than 10. What is interesting to say that the average annual system intactness, which is more or less parallel to uptime, was at 97.7%. Actually, most of the missing of the lost energy could be recovered by cleaning the dirt perfectly. Again, this will be discussed after me. And another interesting number is that 91 event days per system, there were some kind of events. So I think the major issue was actually to customize the alerts to all relevant users, because you have so many issues in each system. But most of those issues are in fact not so much severe. And essentially, you need to reduce the noise. You don't need to alert about a faulted panel every day. It's enough to alert it about once in a while. On the other hand, the faulted inverter, this has to be alerted frequently. And this basically reduces operation by more than 90%. Of course, one thing is to automate everything. Another thing is to prioritize this. And this brings the output of those facilities by, on average, 3 to 7%. In fact, we reduce degradation and improve the uptime because we discover the issues much faster and can alert them much more efficiently. What is also important, we reduce supervisory work by 83%. This proved mainly with municipal level customers because they need to check all the reports and everything involved with O&M quality. And finally, we also found out that reducing maintenance can reach nearly 40%, maintenance inspections, both due to better quality monitoring, which is again automated, and by simply reducing the duplicity of technicians. We often have the case that one technician arrives and then he's identifying the issue that it actually has to do not with electric circuits, but with inverters. And then another technician from the inverter company has to come. So this can be easily reduced. We are now working in Israel. We are soon opening a representative office in European Union. So we have a strategic partnership with the Kfar Saba Economic Development Corporation. Noam will talk on behalf of them later on. We're talking about nearly 20 municipalities where governmental solar systems are installed, or about 1,000 systems overall. We're working also with D-Solar and ISE, who are commercial providers in Israel, each one with a triple-digit number of systems, mainly small commercial scale. And we also work with quite a lot of SMBs, mainly real estate companies and small industries. And we are also in process of joining more partners and customers to our portfolio. Another thing to mention, we are funded by the Israel Innovation Authority as an innovative company. We work in collaboration with some companies. VTS Energy, one of them, as Dr. Igor Dezi spoke on behalf of them, and RST, Rui will talk after me. And finally, Fronius, we had a nice collaboration on developing a REST API by the company, and we beta tested this solution. So in summary, this is what we give, and we are actually welcoming solar integrators, regional energy authorities and solar fleet managers to talk with us and see how we can help and significantly reduce O&M and supervision costs when you manage hundreds and thousands of solar systems. So thank you, and let's move to our next speaker, Mr. Roy, who is joining us from the West Coast, California.